a monomial, binomial, and trinomial. A monomial is just one term. So it could be one term like that. A binomial, how many terms do you think a binomial has? Bicycle has 2 wheels. And so that could be something like 3 plus 2x. 2 terms. Terms are separated by plus and minus signs. Trinomial would be 3 terms, so I could have like 3x minus 2y plus 1. The first thing that you should always look for is monomial factoring. Is there one term that I can pull out from all the terms? That's a way that you can reduce it down. Looking at all 3 of these, what's the greatest common factor that I could pull out of all of those? An x, that's true. This has just 1, so that means I can only take 1 from those. Is that it? So on this one right here, I need a common factor that they all have. They have an x and a 5. They all have a 5 and they all have an x. So I can divide out a 5x. I can take a 5x out. You're dividing out. This looks like multiplying right now. So the opposite of multiplying would be dividing. So the 5's cancel, and then I have 2 x's left. If I took 1 out, there's still 2 left. 10 divided by 5 is 2. 10 divided by 5 is 2. And then when I take an x out, there's still 1 left there. 60 divided by 5 is 12. And there's no more x's left. The x's would cancel. You can always check your work by using the distributive property and multiplying it back together. It'd be monomial factoring. That's the first one you should always check because it'll make the other kind of factoring easier. If you can take out numbers that are really big and bring it down, you will factor a lot quicker. I'm looking at 20. I need factors of 20. What do we have for factors of 20? 1 and 20. 2 and 10, 3, 4, and 5, 6, 7, 8. I'm back on the side again, right? I'm saying 8, 9, 10. Once you get on the other side, you're guaranteed to have all the factors. So I usually just do my divisibility rules up to 10, and that usually wraps me around the other side. Sometimes there's ones that are bigger, but 99% of the time, they're not that big. So I need factors of 20 that multiply together. Well, there they all are. All of those factors will multiply to a 20. I need factors now that are going to add to 9. Add and subtract. 4 and 5. Now I just need to worry about my signs. What do the signs have to be to get a negative 9? They both need to be negative. Negative 4 plus negative 5 is negative 9, and negative 4 times negative 5 equals positive 20. So you're looking for factors that multiply together for C, but add and subtract for B. We're looking for something times something that equals x squared. That would be x times x. And then negative 4 and negative 5 add to negative 9, and negative 4 times negative 5 multiply to 20. Those are my factors. Next one, we're looking for factors of 12. Factors of 12, 1 and 12, 2 and 6, 3 and 4, 5. I'm already on the other side now. I just keep saying that so you can see when you get to bigger numbers, if you keep going down and you start seeing yourself wrap around to the other side, you're done. So there's all my factors of 12. I want you to, let's see, we need a 4. I want you to put any signs that you need to on your factors right now. Test yourself. I know these all multiply to 12, but I need them to add to positive 4. So find the factors. I'm going to give everybody a chance, and I'm going to ask Daniel, what are the signs going to be on the factors that are going to give me a 4? Sam, what do you think? Which factors am I going to use here to try to get a 4? 6 and 2. So once I see that 6 and 2 have a possibility of getting me to 4 miles, what do the signs have to be on the 6 and 2 to get a positive 4? So positive 6 and negative 2 are going to add to 4. And when I say add, I'm talking about integers, okay? And it also multiplies. Negative 2 times 6 is negative 12. I hope there's a negative 12 there. Boom. So I found my factors that work for both adding and multiplying. So I set up my parentheses, put my x's in there, and we know it's going to be negative 2 and positive 6. Again, are you going to do the table on the side? No, most of the time you're not going to. you're just going to go right to factoring. I guess I should say that these all have a 1 in front. The game changes a little bit when there's a number out front. So today is about having a 1 in front. Monday is about having another number that's not just 1. All right, on the next one, so that's how you factor monomials. That's the technique for factoring trinomials. Now we have some other kind of special factors. And if you did your Khan Academy, didn't I assign Khan Academy? Oh, Edpuzzle, that's what I mean, right? So Edpuzzle, there were 2 videos. One was 2 minutes, one was 6 minutes, something like that. And it was about this kind of factoring. Difference of squares. The difference of squares. What do I get every time I see a difference of squares? I get everything that's the same in the parentheses except for that plus and minus sign. That helps me to get no middle term. Everything's the same except the plus and minus. And so here, if I need to factor, I know x times x is x squared. Daniel? Very good. Plus 2 and minus 2. A lot of times you'll see me when the numbers get bigger and I'm trying to figure things out. We can always see the first and last term, but the middle term doesn't always stand out. So I always go like this, inner and outer, when I'm looking at my middle term. 2 times x is 2x. Negative 2 times x is negative 2x. When I add those together, that's why there's no middle term. So if you're trying to figure out your middle term, sometimes you can just look at the inner and the outer, okay? Okay, do the next one, x squared minus 49. X plus 7, x minus 7. That would be the difference of squares. Those are pretty easy to spot. We also have D, a perfect square trinomial. And we're going to start using the shortcut. When I see, here's the formula here for these. When I see a binomial that's being squared, in the homework, we were putting them next to each other and we were expanding them out to be able to multiply, okay? When it was written like this, I can always see my first term, a squared is going to be a squared. My last term, b squared, is going to be b squared. The middle term, you always end up with 2 terms in the middle term that are the same, okay? Like on this one, it would be 3x and 3x. So you can just do 2ab. 2 times the a term times the b term gives you the middle term. If it has a minus sign in it, then it would be 2 times a times negative b, giving me negative 2ab. We're going to practice that. I'm just mentioning it now, and then I'm going to keep drilling it down that we can go right from here to the answer. All right, so we need to factor this. So I'm going to put my 2 sets of parentheses. We know x times x. This is a perfect square, which means you're going to have the same thing in both of them because it's squared. A perfect square has to have the same length times width, side times side. And so if I do, what are factors of 9 that are going to add to 6? Plus 3 and plus 3. Positive 3 and positive 3 add to 6. Positive 3 and positive 3 multiply to 9. My final answer would not to be leaving it like that, would show that x plus 3, there's 2 of them. This affects the graph. It bounces off the graph. Like the x-intercepts that we've been doing, they've been going down through. When we did intercept form, they were coming down through the x-axis because there were 2 different ones. When we have 2 of them that are the same, it approaches and it bounces off the x-axis. So it does matter to have it written like this as a square. Go ahead and do the next one. What's this one going to look like? Negative 2 plus negative 2 is negative 4, and it also multiplies together to be a positive 4. All right, once we know how to factor, then we can solve the equation. We factor it, and then we solve it. So the first thing we're going to do, roots zeros. Those are all the same words. So we're going to factor this, and then we're going to solve it. What are factors of 36? 1 and 36. I'm not going to write it down because it doesn't make sense to have it. 2 and 18 is not close enough together. 3 and 12, 6 and 6. I need something that's going to add to -5. 9 and 4. 9 times 4 is 36. And then I need a -5. What are the signs going to be on 9 and 4 to add together to a -5? -9 and +4 add to -5. And -9 times +4 multiplies to -36. Then I'm only going to do this once, and then I'm going to go right to the answer. Then you set them both equal to 0 and solve. From now on, I'm just going to go right to the answer. So we get x equals 9 and x equals -4. Those are my intercepts. I can graph. Now I have options. Unless the directions specifically say to do it a certain way, which I don't do that very often at all. I let you choose for yourself. I don't have to use x equals -b over 2a in standard form anymore, like we did. I could just go right to factoring and solving and go that way if I want to. Now you have options of different ways of doing it. Okay, factor the next one. Try the next two. Factor and solve. Set up your parentheses, put your x in there, and then think about your factors. When it comes to graphing, it's important to know that you have two answers. It would be true when you're solving. To get full credit, you have to state that you have two answers. And we know what x equals 4, but I'm not going to put 4, 4. We would say that x, because, you know, as we go on, they're going to have 3 answers that are the same, 4 answers that are the same. So how would we say that we have two answers when we're solving? We would say x equals 4, multiplicity 2. X equals 4, multiplicity 2. That means there's two answers and they're both 4. We move on to polynomials in chapter 3. It will say multiplicity 3. You're going to have 3 answers that are the same. Odd means it goes through the graph. Even means it bounces off the graph. That means. All right, example 4, nature preserve. A town has a nature preserve with a rectangular field that measures 600 meters by 400 meters. 600 by 400. The town wants to double the area of the field by adding land as shown. Find the new dimensions of the field. So it looks like they're wanting to add on to this side and add on to this side. Something you should realize about word problems are they always represent what you did for the number crunching. So what was today's number crunching all about? Factors. So you can be sure that your word problem is going to look something like that. All right. Well, I know that at first it would be the area of that would be 600 times 400. So the area is actually 240,000. You know that about it. That would be just for the original one. How could I start representing what they actually want to do here? How would I find the area of the whole entire piece? You're on the right track. So you want to think about how much would this side be worth? 400 to here. Is that it? So how much is this side? 400. If I told you that this was 5, how much would it be altogether? So how do I represent that algebraically then? What you just did in your head, that's how I need to represent this side. So how do I represent it? You did 400, huh? There you go, 400 plus x. So we know that one side is 400 plus x times the second side, because it's area. How much is the second side going to be? 600 plus x. And I know I'm missing a piece of information here. The town wants to double the area. Double the area. So how much is the area then? Yeah. All right. I got myself an equation. I got a variable. What we need to do is we need to simplify this. We need to bring the area, the doubled area, over to that side, and then we can treat it like it's a quadratic. We need everything together on one side before we can do anything. So we start with multiplying 400 times 600, 24 with 4 zeros, and then 400 times x. I should have made more room here. Let's see, that's going to be 400x. I just multiplied 400 times 600, 400 times x. And now I'm moving on to the x times 600 and the x times x. X times 600 is 600x, and then x times x is x squared. I can simplify 400 and 600x. And now I need to bring the 480,000 over and combine it with this number here. So 24 and 24 is 48. And now I'm just going to rearrange it so that my x is first, and I can factor. So they do add to 1,000, and it does still multiply to that. So if I was going to solve this, I would have x equals 200 and x equals negative 1,200. I'd have to reject the negative 1,200 because you can't have area that's negative. Can't have area that's negative. And then I would simply go to that and say 400 plus the 200 and 600 plus the 200. My new dimensions would be 600, exactly what you said. But because this was factoring, I wanted to be able to show that you could use factoring on it. So you reject the negative value because you can't have negative area, and x equals 200. But it was asking for the dimensions of the field, so I had to go back and substitute that in to figure out exactly what times what gives me. All right, find the zeros. And so on your calculator, we've done max and mins. All right, so we're going to go to y equals, and we're going to punch in our equation, x squared minus x minus 12. Graph. Check your window to see if you like what you have there. We're looking for intercepts, so I don't really need to see the vertex. Here's your calculate. We can calculate lots of things about functions, so it's in blue. We're going to do second calculate. And what are we looking for? We've done minimums, maximums. We're finding a 0, number 2. Number 2, we're looking for a 0. All right. It's asking for left bound. It's going to ask for left bound and right bound. When am I on the left-hand side of this? Where would I be on the function? Would I be on the top, or would I be on the bottom to be on the left-hand side of it? That's the question you need to be asking yourself. Where am I going to put my cursor? Am I going to put my cursor on top to be on the left? Or am I going to put the cursor on the bottom to be on the left-hand side of this x-intercept? Right here, if I go straight up to the axis, I'm on the right-hand side of it. So if I go on top and look, if I go straight down, now I'm on the left-hand side of that x-intercept. That's what it means by left bound. You need to be on the left-hand side of the intercept. You hit enter, and then it asks about the right bound. So now I've got to go down on bottom. And when I'm on the bottom and go straight up to the axis, I can see I'm on the right-hand side now. Hit enter, and hit enter again. It says guess, yeah. Enter, and it will tell you that 0 is at -3. X equals -3. So we know x equals -3. And then we need to do it one more time for this x-intercept. So go again, calculate, another 0, and do the right-hand side one. Calculate, number 2 is 0. It's different when you're on the right-hand side. This time, if you're on the left bound, you're going to be on the bottom of the function to be on the left-hand side of it. So I go over, until I'm on the bottom part. Remember, when you hit enter, it brings this little arrow up that says, okay, that's where you said your left bound was. I'm starting to look for the intercept at this place. And now it's asking for a right bound. When I hit enter, that other arrow shows up, and then I hit enter again, and it says 4, 0. So x equals 4. We just found the intercepts. 1.3 assessment. 5, 6 questions. Okay, error analysis. Describe and correct the error in solving the equation. So don't even look at their work. Start with the original equation. Don't look at their work. I promise you're going to keep making the same mistake they make. So today was about factoring. I'm just going to start by factoring. X times x. Factors of 6, they're going to add to a -1. 3 and 2 are close together. That would give me a 1. 3 and 2. And then what do the signs have to be on 3 and 2 to get a -1? That would be -3 plus 2. That would give me my add together to be a -1. And it would, ooh, that's not good. That does not, okay, I see. There we go. -3 and +2 multiplies the -6. So when I solve them, I get x equals 3 and x equals -2. I've just corrected it. Now I want to look at their mistake to see what they did. Look at your work. Look at their work. What's the mistake, Jaden? +2. You just put x plus 2 and x minus 3. However you want to say it. It doesn't matter. You could point to it and say, signs are wrong. Pointing to both of them. You're describing what it is. Again, I'm open to how you describe it, but you've got to describe it and correct it. Find the value of x of a trapezoid. Yikes. Who knows the formula for a trapezoid? Area. So what are you going to do about it? Exactly. Thank you, Jaden. He holds up his phone. Yeah, Google it. All right, there we go. So area equals a plus b divided by 2 times the height. They've got it all there. There's the height, there's a and b. So the area is 32. So we know the area is 32. So I put that where a is. 32 equals a plus b. So x plus 2 plus x plus 6 divided by 2 times the height, which is x.